Dependent and simple independent events. A coin is flipped and turns up heads. What is the probability that the second flip turns up heads? So the first time around, it shows up heads, and each time you flip that coin, you still have a 50-50 chance of heads or tails. So therefore, it is a 50% probability. A coin is flipped 4 times and turns up heads each time. So 1, 2, 3, and 4. What is the probability that the 5th trial will be heads? Well, after the 4th time, these are independent events, and so that opportunity for the 5th head is also still 50%. What is the probability of tossing heads 5 times in a row? Well, each one of those probabilities is 50%, or 1 over 2. And so it's 5 trials. So to the exponent of 5, which is 1 over 32, which is 0.03125 as a probability. The probability of 2 different independent events. A coin is flipped while a die is rolled. What is the probability of flipping heads and rolling 5 in a single trial? Flipping heads is 1 over 2. Rolling a 5 with a 6-sided die, you can get 5 only one way out of a possible 6 outcomes. The word "and" means to multiply, so that probability would be 1/12. Applying the product rule for independent events. Su Ling travels the same route every day. She is determined that there is a 0.7 probability that she will wait for at least one red light, and that there is a 0.4 probability that she will hear her favorite song on her way to work. So in part A, what is the probability that Su Ling will not have to wait at a red light and will hear her favorite song? So we're looking at the probability of the complement of A and B occurring. So that's the probability of the complement multiplied by the probability of B. So the probability of the complement of A would be 1 minus the probability of A actually occurring, and the probability of B is straight ahead. So in this case, it's 1 minus 0.7 multiplied by the probability of B, which is 0.4. So that's 0.3 times 0.4, which is 0.12. In part B, we're looking at the odds in favor of Su Ling having to wait at a red light and not hearing her favorite song. So we're looking at the probability of A and the complement of B, which is the multiplication of A and the complement, which is, again, straight ahead, the probability of A times 1 minus the probability of B. So it's the opposite of example A. So 0.7 times 0.6, which will give us 0.42. And we want the odds in this case. So this would be 42 against 58. Probability of 2 dependent events. A professional hockey team has 8 wingers. 3 of these wingers are 30-goal scorers or snipers. Every fall, the team plays an exhibition match with the club's farm team. In order to make the match more interesting for the fans, the coaches agree to select 2 wingers from the pro team to play for the farm team. What is the probability that 2 snipers will play for the farm team? So we have 8 wingers total on the pro team, 3 of which are the snipers. Therefore, the probability of choosing a sniper as the first winger would be 3 out of 8. For the second sniper, or event B, the only way that can occur to get 2 snipers is if a sniper has already been chosen. So now we're searching for the probability of event B happening given A has already occurred. So we've already chosen 1 sniper here, and we're looking for the second, which means we have a pool of 2 snipers out of a possible 7 wingers. Looking at the formula below, we want both events to occur, so P, probability of event A and event B. Event B is further defined as B given A has already occurred. And so we're multiplying those 2 situations together. And this will be 6 out of 56, which will reduce to 3 out of 28. By the way, the odds would be 3 against 25. Conditional probability from compound probability. Serena's computer sometimes crashes while she is trying to use her email program Outtake. When Outtake hangs, stops responding to commands, Serena is usually able to close Outtake without a system crash. In a computer magazine, she reads that the probability of Outtake hanging in any 15-minute period is 2.5%, while the chance of Outtake and the operating system failing together in any 15-minute period is 1%. So if Outtake is hanging, what is the probability that the operating system will crash? So looking at the formula below, we're actually trying to find out this portion of our formula. So in this case, I'm going to rewrite it so that we've got the probability of A and B, okay, and that's going to equal probability of A multiplied by the probability of B happening given A has already occurred. So I'm just doing some cross multiplication here. So I'm going to key in the values that I'm given in the problem. So 1% equals 2.5% times the probability of B occurring once A already has. Okay, so at this point, I'm going to maneuver it back so the probability of B given A has occurred is 1% divided by 2.5. And that's going to equal 0.4 or 40%. That was a lot of maneuvering of the actual formula. You can use the formula and then sub in your values and solve for the unknown that you need. Thanks for listening.